Let's move forward towards another important phylum in kingdom Animalia, and the phylum is Phylum Annelida. Annulus means rings. Their complete body is highly segmented and having many rings in which are seen externally. But not only it is segmented externally, it is also segmented internally. Means, suppose this is the body of an animal and you can see the segments outside, but the same type of segments are present inside also because of a partition wall called septum or septa. And as septa is present inside and rings outside, the complete body looks segmented. And that's why the name is Phylum Annelida. Annulus means rings. Now, Phylum Annelida shows tube within tube type of plan. Tube within tube means this is the complete organism, and inside that mouth and the complete alimentary canal, and somewhere here will be the anus. Thus, inside the organism, tube within tube type of system is there. Other than the tube within tube type of system, they are coelomates. Means they are having true coelom. When coelom is completely formed by mesoderm, fully the coelom is formed by mesoderm, there is no involvement of endoderm or ectoderm, we call that as coelomates. Means they have coelom. And protostome means the previous embryonic opening is mouth, and that's why protostomes. But other than that, one very important feature of annelids is hydrostatic skeleton. When we talk about hydrostatic skeleton, means each body segment has independent movement. So every body segment has independent functions as well as independent movement, and that's why this is an important feature of their body. Then in annelids, many accessory digestive glands are there. Other than salivary gland, some other digestive glands are linked to the digestive system, making the digestion much easier. Then they have closed circulatory system. So as the circulatory system is closed, heart and blood vessels are there. Long blood vessels are there which run throughout their body. And not only long blood vessels, but their branches are there in each segment. And that's why each segment is well circulated, and that's why blood circulation is much fast, because it is closed blood circulation system. Other than that, paired nephridia. This is one of the very important feature, that they have nephridia. From nephridia only, during the course of evolution, later on nephrons originate. When we talk about nephridia, in nephridia, the specialized it is a specialized structure in which there are mainly two types of openings. One opening is like a funnel, and which is going to collect nitrogenous waste from that segment, and the second opening is in the form of a pore through which that nitrogenous waste is released outside. Thus, there are two openings in each nephridia, and the important feature is nephridia is present in each segment and paired form. So each segment will have two nephridia, and that's why each segment has a excretory pore also. Through that excretory pore, these nitrogenous wastes are released outside the body, and that's why nitrogenous wastes don't accumulate in their body and they can easily get rid of it. Now, amongst phylum Nephridia, there are many classes. Amongst phylum Annelida, there are many classes. Again, amongst phylum Annelida, there are many classes, but out of that, three major classes we are going to see. The very first class is class Polychaeta, which involve polychaete worms, also called bristle worms, as they have many setae on the both sides of their segmented body, and because of that these setae look like bristles of brush, and that's why they are called bristle worm. In that, the most important and the most common example is Nereis. Nereis, also called Nereis verens, which is a motile form of a polychaete worm, and this is its complete anatomy, which we are going to learn now. Now you can see this is the anterior portion, and that's why it is having mouth, but just below, besides the mouth there is a jaw, and that's why, and this jaw is made up of strong chitinous, means chitin. Chitin is a specialized carbohydrate, modified carbohydrate, and this jaw is, that's why this jaw is quite hard, and because of that they can easily trap their prey. Just below mouth there is pharynx, and below that, and this pharynx will come here and meet here in the form of esophagus. Later on the esophagus will continue as stomach, and from that small intestine and large intestine, and here there is the anus. The anus is also called anal syringe. Now the anus, through the anus the unabsorbed food will be released, but this digestive system is connected to many digestive glands, and through that, right from salivary to many other digestive glands, for digesting proteins, lipids and many other food material, and that's why the digestive system is very well developed in Nereis or polychaete worms. Other than that, you can see here there is a brain, but the brain is placed exactly at the center, towards a little bit towards the ventral side. So suppose this is the Nereis, then this will be its ventral side. So on this side somewhere there is a brain, and you can see that that's why cephalization is taking place in them. But from the brain a long ventral nerve cord will come. So they don't have a dorsal nerve cord, they have a nerve cord towards the ventral side of their body, and that's why it is having many branches, and that's why having good regulation on the body. Other than that, you can see just besides brain there are 4 eyes through which light can be sensed, and other than that there are 4 sensory projections are there, and 2 antennas. They are going to sense the surrounding as they continuously keep on moving in that area. Now other than that, you can see nephridia, as discussed just now. Nephridia is present in each segment. Pair of nephridia is present in each segment, and we have shown only limited nephridia here, but that is present in each segment, and these nephridia are having pores also, which will open on the ventral side, means on the downward side, but every segment will have 2 openings, and every segment has 2 nephridia which are coiled. Now other than that, the most important feature of them is the parapodia, which is present almost from the second segment to the up to the last segment. The first segment is not having the nephridia, not having the parapodia, but right from the second to all other segments they are having parapodia. Now this part is called, the head region is called prostomium, and prostomium is a region where actually eyes and brain are located with antenna and sensory projection. But immediately after that starts segmented body, that is the elongated body, and with parapodia. On every segment there are 2 parapodia, that is a pair of parapodia. The parapodia are used not only for swimming, but they are also used for respiration, as they are involved in gaseous exchange, and that's why they themselves can show the respiration also. And parapodia are attached to setae. The setae or setae are also called chaetae, and that's why, because these chaetae are attached, they are called polychaete worms. And these setae are actually like bristles, and being these setae are like bristle-like, we call them as bristle worms also. Other than that, you can see they have a closed circulatory system. So here there is a heart. After 2 or 3 segments we have heart, and from the heart you have ventral as well as dorsal blood vessel. But as discussed, both the ventral as well as dorsal blood vessel. So if this is the organism, somewhere here there is a heart on this side, and ventral as well as dorsal means on the ventral as well as dorsal side we have quite good blood vessels. They run throughout their body and they have branches in every segment. It's closed blood circulation system. Then let's come to their reproductive organs, and you can see in they are, first of all, they are unisexual, means male Nereis is different than female, male polychaete worm is different than female polychaete worm, and they have pair of gonads almost in many parts of their body. So amongst that, you can see here somewhere we have shown testes, but such testes pairs might be present in some other parts of their segments also. In certain polychaete worms, pair of such gonads are present throughout their body, but we have shown here only one particular pair. If it's a male, it will be testes. In case of female, it will be ovaries. Then they will definitely produce sperms, and through sperm duct, and then after that sperm duct, here there is either male genital pore, or in case of female, here there will be oviduct and they will have female genital pore. Now this is their reproductive part of their body. Now these Nereis, they reproduce only in breeding season. Yes, they can't reproduce throughout the year, and in breeding season only many such polychaete worms, they come close to each other and they share a portion of their body containing immature eggs or sperm. So they don't have clitellum, just like earthworm. So it's not clitellum in them, but they are part of their body which will collect sperms from male, and ovaries, the ovum or female gamete from female. That part is shared outside their body, and that part is still containing immature male gametes in case of male and female gametes in case of female. And these are parts which are released, which contain male gamete and female gamete. From that, the sperms will come out after maturity, and these sperms will travel up to the female gametes. Fertilization will take place and zygote is formed. And this zygote very fast, very quickly, it develops into a larva, and very fast the larva will show metamorphosis to form adult. Adult means segmented body. So this is how fertilization, that is reproduction, takes place. Thus the reproduction is, or the fertilization is, external. But in a few species only, copulation, that is internal fertilization, is also seen, but that's very rare or in very few species only. Other than that, amongst Polychaeta, amongst polychaete worms, there are animals like Christmas tree worm. These Christmas tree worms are also called Spirobronchus giganteus, and these look like the open funnels. So their body is something like this, open funnels, but with many cilia surrounding their mouth. And that's why the cilia will always keep on forming a water current like this. And because of that, the small animals which are present around them will be captured and introduced inside. But these Christmas tree worms are sedentary, that is, they are sessile, they are fixed at one place. So such organisms are also there amongst polychaete worms, but the most common example is Nereis, which we have seen just now. The next most important class in phylum Annelida is class Oligochaeta. When we talk about Oligochaeta, the most important example of it is earthworm, nothing but lubricus. And we are well familiar, earthworm is called friend of farmer. Why? The reason is the waste which it removes through its anus is rich in nitrogen and various nitrogenous compounds, and that's why more the amount of earthworm in any soil, more is the fertility of the soil. Vermicompost is such a field which is attached to that, and that's why economically also, or from environment point of view or agricultural point of view also, earthworm are very important. Now, in earthworm, that is class Oligochaeta, no well-developed head or parapodia are there. In the previous example of Nereis, we have seen there were parapodia throughout the body. Now this is a common anatomy of earthworm, and you can see that there are setae are present. These small projections are the setae which are present, and they are present throughout the body. Every segment of their body, as the body is highly segmented, every segment is having a pair of setae. But there are no parapodia. In Nereis we have seen there are parapodia, and from that bristles of setae are originated. But that is not the case with earthworm. Now, and that's why no well-developed parapodia is there, neither head. Now, setae protrude directly in pairs from the surface, and each segment is carrying setae. Locomotion is through muscular contraction. And in muscular contraction, especially in its locomotion, a few important things are there. That they have longitudinal muscles which contract first. So suppose this is an earthworm, they have throughout their body longitudinal muscles, and these longitudinal muscles, they contract first, and as a particular region of their body contract, immediately after that the segments bulge. When the body will contract, no doubt the body is highly segmented and the segments will start bulging. Setae protrude into the soil. The setae which are present, they will protrude into the soil. Once the body will move forward, these setae in this area where the segments will get contracted, the setae will go into the soil and they will protrude. And after that, these are about the longitudinal muscles, but they have circular muscles also throughout their length. So one set of circular muscles, second set, third set, fourth set, like this throughout their body. Each and every segment is having circular muscles also, and these circular muscles will now contract. When these circular muscles will contract, this part of their body get shrink. Because of that, the setae which are present in this area will detach themselves from the soil. Circular muscles contract and the setae are withdrawn. Setae in this area are at present in contact with the soil, while setae in this area are now withdrawn from the soil, and thus the segments will move forward. In this way, the longitudinal muscles will first contract, the segments will bulge in this area, they will form new contact with the soil, the setae in that area will go in the soil, the setae in this area, as the circular muscles will contract, the setae in this area will detach themselves from the soil, the body will move forward. In this way, with the help of longitudinal muscles, then circular muscles. Again, longitudinal muscles, circular muscles, they will keep on moving, just like compression and rarefaction type of longitudinal waves. And this is about their locomotion. Then, moisture is extremely essential, because in them, respiration takes place throughout the body. And that's why body should be moist, body wall should be moist, and as gas exchange is taking place through it. That's why moisture is extremely essential in the soil. Now, they, while moving, they are the scavengers, and that's why they will keep on eating everything in their path. Everything which is easy to eat, everything which is easy to swallow, that everything in their path they will keep on eating, and that's why they will keep on making the soil porous. And this is because the muscular pharynx which they have, the pharynx region of their body is quite muscular, and that's why it is easy to swallow for them. But during that, the food is stored in the crop, yes, in their digestive system, immediately after esophagus. This is the mouth. This is the esophagus, and the esophagus will continue as crop. Crop is that part of the stomach which is going to store the food. So they can store food here in this region, that is called crop. But immediately after crop will continue, it will continue as small intestine, where a part is there that is called gizzard. And gizzard is having a tough muscles which is generally present from 8th to 9th segment in the body, and in that it will help in ground up of the all soil particles and the dried leaves and whatever they have eaten in their body, all the organic matter. After that there is a continue and a very long small intestine, and this is the small intestine, and then continue as a large intestine, and finally anus, and this is their complete digestive tract. But this small intestine region, which will start approximately from 10th segment and continue up to approximately 70 or 80 segment or 75 segment, and in this there is a region called typhlosol. Typhlosol is nothing but the it's a projection from, or it's nothing but a folding of the intestine, which will increase the surface area of the intestine. And it is, typhlosol is present generally from 23rd to 75th segment, because after that, and main function is absorption of as much food as possible from the small intestine. But after 75th segment or 80th segment, there might be large intestine where absorption of the food is not going to take place, and that's why there is no typhlosol after that. And large intestine release the wastage which is rich in nitrogen, which we have just discussed. Now look at this. This is a normal earthworm anatomy, and you can see here, just now we have discussed about the digestive system, but if I will take a cut of digestive system from this area where there is a small intestine area, you will came to know this is the intestine, this one is the intestine, this is their body, and these are the longitudinal muscles which we can see here. And other than that, immediately after, outside the longitudinal muscles, there are circular muscles. So longitudinal muscles and circular muscles both are present, and this is the intestine, and this is a part of the intestine which is folded, and that is called typhlosol, and from that the food is going to move. If intestine would have been simply circular, for absorption there will be less surface area, but now there is more surface area for absorption. Now other than that, throughout each and every segment is having nephridia. Nephridia is a coiled region which will have two openings. Through one opening, which is like funnel, it will keep on deriving nitrogenous waste from each and every segment, and through the pore which generally open on the ventral side. So all the pores of nephridia in each and every segment will open on the lower side, and through the pores the wastage is released outside. And throughout their body, such many nephridia are present throughout each and every segment of their body contain nephridia and nephridial pores. And now you can see in the TS, that is transverse section of earthworm, so you can see these are the nephridia region which will collect nitrogen space from the coelomic from the coelom and release it through this pore outside. This is the nephridia, and it is releasing it outside. Then other than that, brain is present on the comparatively the just above the esophagus, on the dorsal region there is brain, but from the brain a long nerve cord will come, and the nerve cord is ventral always. So this green part which we are showing is actually the nerve cord, but that is ventral, but lots of branches of the nerve cord are there throughout, and that's why having a good regulation on the body, a good neuronal regulation throughout the body. Other than that, this is the heart. You can see heart is also in the anterior part of the body, and there are 5 pairs of heart. Here we are showing only 5, 1, 2, 3, 4, 5, but such 5 are present on that side, means on the ventral side, and 5 are present on the dorsal side. So 5 and 5, such 5 heart are there, and all these are attached to each other. All the 5 pairs of heart are attached to each other. There are 2 main blood vessels. One is the ventral, which is present on the ventral side. So suppose this is the earthworm. Throughout the ventral side there is a long blood vessel. This is the ventral one. Then there is a dorsal blood vessel is also there, and they are attached to all the 5 pairs, and that's why having a good control on circulation. Earthworm has hemoglobin in their blood, and that which is going to carry oxygen throughout their body. Then, other than that, if we will discuss about the reproductive organs of their body, as we have discussed that throughout their body the body is highly segmented. Look at this, the body is highly segmented. But earthworm is hermaphrodite. Hermaphrodite means bisexual. So the same animal will have both male reproductive system as well as female reproductive system, but they are protandrous. Means the male reproductive system will mature earlier as compared to the female, and that's why the male reproductive system, which consists of 2 pairs of testes, 2 on this side and 2 on that side, and in this way on the 2 lateral sides of their body the 2 testes are 2 pairs of testes are present, and from the testes you can see this sperm duct will come out, and that will continue as vas deferens. Testes are present on the 11th and 12th segment generally, but you can see the vas deferens which will carry the sperms, that is the sperm duct, will open on the 18th segment where there is a male genital pore. So though the testes are present on the 11th and 12th segment, but the long vas deferens will open in the form of male genital pore in the 18th segment of their body. But as they are hermaphrodite, ovaries are also there, but ovaries, there is simply 1 pair of ovary, and these ovaries are at the 13th segment of their body, and these ovaries will have, here you can see the 2 cup type of structures which will open in the form of oviduct or female genital pore on the 14th segment. So the female reproductive system is comparatively very simple. They have ovaries on the 13th segment, and 14th segment will have oviduct, that is oviduct and pore, that is female genital pore, 13 and 14. But male is comparatively longer. But on their body there is a region called clitellum is present, and clitellum is present from 14th to 17th segment. Here from 14th segment, don't forget on the 14th segment we have female genital pore also. So the 14th, 15th, 16th and 17th, these 4 segments are joined, and you can see a ring type of structure because all the 4 segments in that area are fused with each other. A bulge type of structure can be seen which is called clitellum, and this clitellum is going to play an important role in its reproduction. Let's see how the reproduction is going to take place. Now you can see here that this is one earthworm, and as we have discussed, in this earthworm, as earthworm is a bisexual organism, in this part of his body you can see this is the 14th segment which is having the female genital pore, and these are the ovaries, and on the of course no doubt 11th and 12th we have male reproductive system, and no doubt this will open at the 18th segment, the male genital pore. But this 14, 15, 16, 17 are having clitellum. You can see that clitellum is there. And now what will happen after that? That this particular part of clitellum, as the female gametes will mature, it will collect the female gametes from this area, and this clitellum will be ready after catching the female gametes. But this is one earthworm like this, and now there is another earthworm which will lie like this. So one earthworm and this is another earthworm, and both the earthworm, this is called cross fertilization, both the earthworms will be in contact with each other just like this. This is called cross fertilization. The 18th segment of this earthworm, you can see this earthworm, and this 18th segment of this earthworm, which is having the male genital pore, will attach with the 6th, 7th, 8th or 9th segment in this earthworm. So this is first earthworm, and on that the 18th segment of this, which has male genital pore, will come in contact with the 8th or 9th or 7th or 6th segment. Now the 6th, 7th, 8th, 9th segment of this earthworm, earthworm number 1, will have spermaticle. Spermaticle means these are such pockets in which sperms can be stored. And you can see the male genital pore of this earthworm will transfer its sperms in these spermatical bags. When it will transfer these sperms in the spermaticle will store the sperms, because along with sperm mucus are also transferred, and that's why here in this area the sperms are stored. After that, whenever in this earthworm number 1 the clitellum start moving from posterior part to anterior part, and this is the anterior part, segment number 1, 2, 3, 4, and it will start moving towards the mouth region, and by collecting female gamete from this area, and when it will start traveling from this region, the clitellum will start traveling up to this region where it will collect sperms also. The sperms of the second earthworm, which it has released here during copulation, and thus you can see the female gametes from this area of this earthworm number 1, and as the clitellum will move, it will come in this area where there are sperms collected from this earthworm number 2, which we have shown by red color, which has transferred its sperms. And now when this clitellum will come out of their body, you can see it will have many ova or female gamete and many sperms. Sperms are shown by this red color and ova with this blue color. And now this portion which is released here, actually fertilization will take place. That is, the male gamete, that is sperms, will unite with females to form zygote, and these zygote will now develop into new earthworm. But this part of the clitellum which has come out will show a band-like region, and which looks something like this. This is called cocoon, and in actually the cocoon zygote formation takes place. Thus earthworm number 1, earthworm number 2, this earthworm, this second earthworm will transfer its sperms in segment number 6, 7, 8, 9, come out of it. The clitellum, which is a part of their body, suppose this watch is a clitellum, and it will collect, which will start getting detached from the body. It will collect ova or female gamete, and then it will start moving slightly towards this and collect sperms from spermaticle, and this part will come out of it. And this part of the clitellum which will come out will have now sperms as well as ova. Here, after proper maturation, the sperm will combine with ova to form zygote, and this shaded clitellum is going to develop into cocoon, and this cocoon will have many zygotes. These zygotes are actually going to develop later into earthworms. This is how reproduction is going to take place in earthworm. Another important class in Phylum Annelida is class Hirudinea. Why the name is Hirudinea? Because these animals secrete a particular chemical called hirudin from their saliva. The most important example of it is leech, that is Hirudinea. Why is this so? Because leech is a bloodsucker. Most of the animals in Hirudinea are bloodsuckers, and that's why when they because of the big tooth which they have, they insert them, and a small proboscis which is present inside them, they will insert that proboscis, exactly find where the vein is, and through that vein they will keep on sucking the blood. They most of the time suck blood of mammals, and through the blood they keep on sucking the blood until and unless their stomach is full. And during this, our blood clotting factors may clot the blood, which may clog their way to suck the blood. To stop this, they keep on secreting hirudine. Hirudine is mainly secreted by their salivary glands. This is a common anatomy of leech, that is Hirudo medicinalis, and in that you can see they have two suckers. One is an anterior sucker in which there is mouth. Mouth means you have jaw, teeth, and that's why main feeding is taking place through mouth. But there is one more sucker, and that is the posterior sucker. On the posterior side also there is a sucker. But here there is anus, and the main aim of this sucker is leverage, that is exertion of force. So when a leech is there, it will bind the body through anterior sucker as well as posterior sucker, but through anterior sucker only sucking of blood will take place, but from posterior sucker it will keep on giving force on the body, and that's why it is used for only leverage and not for the purpose of feeding. Now, in case of leech, the body plan is quite same as earthworm, which we have already seen, but no setae are present, and as setae are not present, definitely their movement is quite different than in case of earthworm. Now, each body ring has several transverse grooves. So every ring has several transverse grooves, they are present, and because of that their body is a little bit more rough as compared to other animals in phylum Annelida. Then hirudine, that is anticoagulant, is secreted. The modified form of hirudine, the chemically synthesized form of hirudine, is heparin. Heparin is an anticoagulant which is generally used in the pathology laboratories. Clitellum is seen, but clitellum, as it is always present in earthworm, in leech clitellum is only seen during reproduction. But other than that, cuticle is present, which is thick. Circular as well as longitudinal muscles are present, and longitudinal muscles are there, so they will keep on contraction and rarefaction, and circular muscles are there which will keep on contracting their body during movement, and that's why the movement is quite flexible. Now, let's take a look of its complete anatomy. As usual, which we have discussed, there are two suckers, anterior as well as posterior, but on the anterior side there is a mouth. Through teeth they will bite to the surface, and through that there is a proboscis. You can see that proboscis is here, and the proboscis is highly coiled inside. We haven't shown that, but it is highly coiled, and it's released exactly into the vein of a person. Then you can see this is the esophagus, and esophagus will continue as crop. Crop is that stomach in which is mainly used to store food. And here there are salivary glands. Keep in mind, all annelids have salivary gland as well as many other digestive glands. Doesn't matter whether it is earthworm or it is leech. In that, salivary and many other digestive glands, accessory glands for digestion, are always present. Then after crop, you can see there are some more stomachs are present, and they will continue as small intestine and later on into large intestine, which will end up as usual into anus. But through small intestine, proper digestion will take place, and not only digestion but absorption of the food will also take place through small intestine through blood vessels. Now, you can see, as it's an important feature of complete phylum Annelida, that they always have nephridia. You can see these nephridia are shown here. Every segment of their body always have nephridia, just like earthworm, and nephridial pores are also present. So suppose this is their body, then every segment will contain nephridia, and nephridial pores will open on the ventral side. So Nephridia has two pores. Through one, it will keep on absorbing nitrogenous waste product from the coelom, and through the other, they will continuously, that is the excretory pore or nephridiopore, they will continuously keep on releasing the nitrogenous waste outside the body. Now, you can see that this is their heart, and there are 10 to 15 chambers of heart are present on right side as well as the left side. So left as well as right, both the sides consist of 10 to 15 chambers of heart, and all these chambers are joined to each other, and many blood vessels are there. You can see these longitudinally the blood vessels are running, but not only longitudinally, they are completely, there are many branches of these blood vessels, they are throughout spread. Like this, many branches are there which are spread throughout the body of leech. Then, leech is hermaphrodite. Hermaphrodite means both male and female, both the sexes are present in the same animal, in the same organism. But you can see this is the male sex organ, and that is called testes, and there are 9 pairs of testes. 1, 2, 3, 4, 5, 6, 7, 8, 9. They are kept such longitudinally throughout the body, and these 9 pairs of testes will here meet at seminal vesicle, and later on through the secretions of seminal vesicle and 9 pairs of testes, these sperms can be released outside through male gonopore or male gonadopore. Then exactly below that there are 2 pairs of or 1 pair of ovary, one on the right side and second on the left side, and both the ovaries are joined here through oviduct, and here there is a female gonopore or female gonadopore. Now, leech is also protandrous, just like earthworm. This means in leech also self-fertilization cannot take place, because the male gametes will mature earlier as compared to the female. And if the male gametes will mature earlier, and if they are ready for fertilization but the female gametes are not ready for fertilization, in that case definitely self-fertilization is not possible. Again, what takes place is a cross fertilization. Suppose this is one leech and this is its anterior side and this is the posterior side. Then this is the second leech, and you can see its anterior side is opposite and posterior side is opposite as that of the one leech. So there is cross fertilization. And now during reproduction, again now clitellum is seen, and clitellum as usual has the ability to move throughout the body. So what will happen, that this one of this leech will transfer its male gametes, that is sperms, in the second leech, and now these male gametes, that is sperms, which are transferred are stored in a part in leech. That part is called spermaticle, and just like in case of earthworm. And now here in the spermaticle the sperms are stored. After some days the clitellum will start moving, and as usual the clitellum will first carry the female gametes, that is ova, and now this ova or female gametes, this clitellum with female gametes will start sliding on a leech, and later on it will pick up sperms from here, and from the anterior side the clitellum will come out. Now in this clitellum you have ova as well as sperms, and they will now fuse to form zygote. And these zygotes will develop into new leech. This is how the reproduction is external, but copulation is taking place, because one leech will transfer its sperms in another leech, and through the clitellum which is moving throughout it, it will carry first the female gametes, and then the male gametes released by the another leech, and then this clitellum will come out and shed outside. After a few days it will develop into cocoon, and this will form zygote, and later on the zygote will give rise to a new individual. This is how fertilization takes place in leech. One more important feature in the class Hirudinea is their specialized nervous system. And in case of their nervous system, you can observe that there is a central ganglion which is present, a cerebral ganglion which is present on the uppermost part, and that is in the anterior part. And from that a ventral nerve cord will originate, and this nerve cord will run longitudinally along their body with many such paired segmented ganglions. So many ganglions are present throughout their body with many segments throughout, and thus they have a very good control on their body. This is about their nervous system. Thus, there are three major classes in the phylum Annelida. First, Polychaeta, second, Oligochaeta, and third is the Hirudinea.